What's up, math scholars? This is Mrs. Harp here, and we are coming at you with a 7.4, 7.5 math video. This is day 2 of the lesson, and today we're going to focus on a few more practice problems with exponential growth and decay, but we're also going to learn how to go into Desmos, put a table of values in, and then have Desmos fit a line to the table. It's called a regression line, and we did regression maybe a month or so ago. So it will be something you've seen before, now with exponential growth. So go ahead, I'm going to pause the video and let you guys work on this, and then we'll get a volunteer up. This is just a review of what we learned last week. Okay, we had a student come up here and show the work, and you can see where all the values got put in. It's a 0.05, it's hard to see that decimal point, but the final answer is 877.58. All right, here's our next problem. It's a depreciation problem. What does that mean as far as our formula is concerned? We'll be subtracting. Very good. So pause the video, you go ahead and try it, and we'll get somebody up here to teach it. All right, thanks to a student volunteer. She talked about depreciating and how you have to have a subtraction sign there. And she also discussed finding out that there's 12 years between 2030 and 2018. You can subtract those years. And that gave the final of $3,005.79. All right, one last practice problem. I'm going to give you some advice on this one. Let's read it together. There were 10 rabbits, and their population was tripling each year. How many rabbits will there be in 13 years? We're not really dealing with money, are we? We're not really depreciating. We're not really earning interest. So you don't actually want the formula we've been using. You want the most basic exponential growth and decay equation, where A is the starting amount and B is the growth factor. So I'll let you try some ideas and see if you can figure this out. The answer will be very large because there's going to be a lot of bunnies. Alrighty, there's your answer. She put a 10 in for her starting amount, a 3 for her growth factor, and a 13 for the year. So you can see the answer is over 15 million. Alright, so now we're going to look at those 3 that were on the homework, and I'm going to give you my advice for the best way to come up with the equation. So first decision you want to make is growth or decay. Did you bring graphing arms? Everybody make your growth equation. Ready? Go! Growth! So it's going up as time goes on. And decay? Boop. Decay. So what do we have here? Growth or decay? Which really, it doesn't matter if it's growth or decay. This is the formula we'll be using. Decay just means that our growth factor, this guy, will be a number between 0 and 1. So it's kind of good to say to yourself, this is decay, and then check that you picked an appropriate growth factor. A is going to be your starting point. Now, a starting point on a graph is nothing more than a y-intercept. So what is the value of the y-intercept on this graph? Where is it touching the y-axis? This is our y-axis. Where's it touching the y-axis? Ding, ding, ding. Right here at 3. Oh, you're going to say 3? Good. Yeah, right there at 3. So you're going to put your 3 in for A, and then your x remains your exponent. The only thing else we need to figure out is our growth factor. Now, in all of these problems, if they don't give you a coordinate at 1, you can go ahead and make one, but we will give you a coordinate at 1 for all the problems we make for you. Now, with exponential growth and decay, they're repeatedly multiplying by a number. It's called the growth factor. So they just multiply by that number. They multiply by that number again. They multiply by that number again. So to work backwards, you want to take the number on the right and divide it by the number on the left to figure out what they were multiplying by. So type in 2.25 divided by 3, and that'll be what the constant multiplier was. And what is 2.25 divided by 3? Yeah. Yeah, and that's going to be your growth factor. And I can check, yep, that growth factor is a number between 0 and 1, so it would lead to decay. And this particular one you could check is 4 times 0.75 going to give you 3. You can check that. And it does, so you got it right. Okay. What do you guys think this would be, growth or decay? Are the values getting bigger as we travel to the right, or are they getting smaller as we travel to the right? Smaller, so it's decay. Here's our equation we're using. Let's start with the starting point. That's the y-intercept. Where's our graph touching the y-axis? 2. Very good. Now we got to figure out our growth factor. So we're going to take the value on the right, the 1.4. We're going to divide it by the 2 to figure out what they had multiplied by. So 1.4 divided by 2. Some of you might be able to do it in your head. 0.7, sound about right? And that is an appropriate growth factor. It's a decimal between 0 and 1. So it would lead to decay. Right, one last problem before we head to Desmos. All right, is this one growth or decay? Definitely growth. It's getting bigger from left to right. Here's my formula. What's the a value? The y-intercept. Good. And then to figure out what they're multiplying by to get from here to here, you can take your 8 and divide it by 4. Did you get 2? That's the formula. Just make sure your formula has both an x and a y in it. These formulas have that both. All right, so what we're going to do now is fire up Desmos, and we're going to talk about putting a table in and then having Desmos fit either a straight line to our values or maybe an exponential curve to our values. All right, so we're in Desmos. We're going to use this drop-down arrow to add a table. And then the table of values that I had on the slide were right here. I went ahead and wrote them on the whiteboard, though, to help out the students. Let's go with -1. Enter. 0. Enter. And after a while, they figure out what you're trying to do, so they know what you're going to do. But we don't want 3. Clear that one out. All right. Your y1 column is 50, 10, 2, and 0.4. And then I like to just zoom it out so I can see all my values. And I like to think to myself, do they look like they're making a straight line, or do they look like they're making an exponential growth curve? What do you guys think? They look like a straight line or an exponential growth curve, or is it too hard to tell? I mean, you can tell right here. I don't think these are in a straight line. So is this exponential growth or decay? What do you guys think? Decay. The values are getting smaller as we go through time. So here's how you do a regression line if you have forgotten. You have to use a tilde. Do you remember using a tilde in here in Desmos? You're going to do y1 tilde a times b. And for the multiplication, I use the star. It's above the 8. I think on the keyboard you could use, right here, you could use it there too. And then to make your exponent, I use the caret key, which is above the 6, but you could, again, use your keyboard and use this button. That'll get you an exponent. The exponent needs to be x1. And then if you did it right, a little purple regression line should appear, and it goes through almost every dot. Yeah, actually, every single dot. It's hitting that dot up here. It's hitting the 3 dots down here. So it hit every single dot. Awesome. Now let's explain what we're seeing. The r² value is explaining to you how good of a fit the line is. This is a 100% fit. And now the a and the b, those are the a and b values. So I'm going to have you go down here and actually type in the equation of this line, just for practice. It'd be y equals a times b to the x, or y equals 10 times b, 0.2, there we go, to the x. And if your purple line and your black line are right on top of one another, then you did it right. Okay? All right, we have a new table of values. We're going to go ahead and stick in Desmos. Let's head over to our Desmos. You can clear out your old things. I would actually keep your regression line because you're still going to be trying to make a regression line. Let's just change our values. So our first entry is a -11. Our second entry is a -7. Our third entry is a -3. And our fourth entry is a 1. And then I'm going to scroll around so I can find my table. Looks like my purple line is still there. Oh, that's my regression line. Unfortunately, does it look like my regression line is fitting my green dots? In fact, if I look right here, it's only a 90% fit. Any ideas why? What's going wrong? I need help. Where's my scholars? Why is my regression line just not fitting this data set? Someone knows. Think hard. Maybe this data set, let's look it up again. Maybe this data set is not exponential growth. Look, from -11 to -7, they're adding 4. From -7 to -3, they're adding 4. From -3 to 1, they're adding 4. So this is actually a linear example. A straight line would best fit these values. So we're actually going to make a straight line regression line. Y equals mx plus b, but you have to use a tilde. So y tilde m, lowercase m, times x, we'll make it x1, plus b. It's a perfect fit. Now my r value is a 100% fit. You can see it. My m value, my slope is 4. My b value is -7. And I'm just going to write that equation out for practice. Y equals 4x plus 7, well, minus 7. And then you can see your red line fits right over top of your purple line. It's a perfect fitting line. All right, we got one more data set to put in Desmos. This is our last example of the day. So I'm going to clear out this. I'll probably clear out this because it's probably not going to be linear. And then let's change our numbers. It's a 2, then an 8, then a 32, and then a 128. I can tell right away this is not linear. Look how it's starting to grow slowly and then starts growing real fast. So you can kind of scroll out to see all your values. Whoa, one's way up there. So there you can see all 4 of them. They don't look like they're going to be a straight line. They probably, my guess would be exponential growth. So let's do our regression line. Y tilde a times b to the x. It has to be an x1 and a y1. So I messed up. It needs to be a y1. I'm sorry. Y1 tilde a times b to the x1. Perfect fit. When your r squared equals 1, it's almost like you hit the lottery. It's a perfect fitting exponential growth line. It goes through every single one of our green dots. See? And then just for fun, let's type out the equation that gives us. Y equals a times b to the x would be 8 times 4 to the x. So there's my green line. I guess blue was my regression line. Okay, so we're good. Do I need to come help anybody? Okay, your homework tonight is actually in Desmos, but I'm going to give you a piece of paper that has the data points on. You are going to need a class code to get in, and it's student.desmos.com. So how about everybody go to student.desmos.com and try logging in with the correct code, and then you'll be good to go, all right?